So while my friends are getting ready here, I'd just like to start. This will come from a very different perspective than you are probably used to. It begins with a philosophical perspective. In his book, I'll be reading mostly from notes as I had to squeeze this down to the 15 minutes. And thank you, Stefano, that was a very interesting chat. In his book on method, Paul Feyerabend identifies that there is just one body of knowledge. I think we all know this, but most of us don't pay a lot of attention to it. All the correct parts of physics, mathematics and philosophy must and can only be different ways of perceiving the same world. That world must be reasonable and rational. If it was not, it would be separate from itself, which makes no sense, it's inconsistent. We rely on empirical methods to produce our science because when we attempt to derive models of the world from an a priori perspective, just straight out of our mind, a rational perspective, the result was, 2,500 years ago, absurdity at every level. It led to all sorts of problems, and they struggled with it for a time and then gave up because no one could see a way that you could go forward. I'll touch on that in a minute, so I won't be leaving you hanging, I hope. From this, only one other option seemed to be available, and that was empiricism, the way we do our physics. We take a measurement, we use the measurements in our observations to derive what we call knowledge, but that comes with a cost. Are we right? Apparently not. Okay, well I'll keep going until you're ready, okay? All right. The unexpected discovery that the universe accelerates reminds us that all theories are paradigms because our knowledge is founded on empiricism. Knowledge based on the world as it appears to be to us, not necessarily as it is in itself. It might be, but we don't know. Okay? Hence at foundation, such theories are entirely and inherently, not entirely, they're inherently descriptive. We're good? We're good. Okay, let's see if I can work this thing. Yes. Okay, why and how the universe computes. I'm going to be considering the thing on the left may be the thing on the right. All right. Inherently descriptive. In contrast, Einstein wanted physics to produce ontic equations, which capture the causal mechanism. My work is about the causal mechanism, not about the vast descriptions of the wonderful things that other physicists who presenting yesterday and this morning are working with, although that should come out of it in the end. Okay. Do the thing. Okay. A question from Stephen Hawking. It's a very good question. Finding Hawking's fire requires an ontic condition, a condition of reality that causes change. The standard axioms of quantum mechanics imply that at the limit of continuous observation, a quantum system cannot evolve. For if the universe is some kind of computer, what creates the computer? And what drives the computation forward? I will argue that both computer and driver originates in a global principle of equivalence, or at least a condition that is modelled by a condition of equivalence. John Wheeler foreshadowed an a priori explanation. Recognising that one must identify an immaterial source for the world. Let us derive an account of existence and time and space His immaterial source is a politician's way of referring to first cause. This has been asked before by some very big names. So from his immaterial source we seek the laws of the universe. Now this is just to give you a little about me, I suppose, but also I'll give you a little background how I was forced to do what I've done. Let me just grab my other glasses. No, it's not there. Okay, it'll be right. While studying toward my degree in physics, here. Sorry, to you it would be there. Okay. While studying toward my degree in physics, I stumbled on a foundational problem that led to a global set of xenotype paradoxes. It was 1996, and I was here in Charleville, in the Australian outback, learning physics by correspondence. It was a bit quiet there. I needed a telescope for some coursework, and ended up finding this. It just kind of happens that way. In solving the paradoxes, I arrived at a world model. There were hints of quantum mechanics in there, but I could not see how to connect my a priori model to our a posteriori world. Then 3 years ago, I bumped into these men's work and the information universe. There it is. Okay, and I thought, oh, so that is what I have, I think. Let me set out the model and its foundation, an ontological principle mirroring that ontic condition of the world that I mentioned before. To do that, we actually have to start with ourselves. We must begin with how we come to knowledge. To identify a well-founded ontological model, as opposed to an ontological model, which is a best guess based on facts that we can see out in the real world, yes? One must address this question, because if one can establish something that is immune to doubt, one is bound as a matter of intellectual honesty to accept such as a proper model of an actual condition of the world. Then we might determine which of these will conform to that condition, or select between Padmanabhan's models yesterday and Verlin's theories, for example, or the ones that you were mentioning before, Stefano, and you'll see there is a correlation later on yourself, I think. So let's just have a look at this. Okay. While I must paint in broad brush strokes here, each point has a terse proof if you wish to challenge me on it later. There is a problem for the idea of the smooth continuum, exemplified by Zeno's arrow paradox, which is that time is necessarily made of moments, and within any moment, motion is not possible, and there can be no motion between moments, so an arrow in flight cannot move. Motion is impossible, according to Zeno, and no one's ever been able to show a solution to that, including Hilbert, Gödel, Riemann, you name it. Okay, so when I tried to chase this down, when I analysed the problem from mathematics, the geometry, whether Euclidean, Riemannian or any other, and axiomatic set theory itself became vastly inconsistent. No number of points, countable or uncountable, could cover the line. So what I'm doing there is, if you have a look, all we've done there basically was we started with a very simple thing. There's a certain distance on the upright and the one to the right, and then if I just rearrange that, I get this. And you can see that it would be able to be reconsidered and reconfigured all the way down. And in the end, we just end up with, I could have cut that up any other way, and I find that there's no way that any of those points can fall on, none of those points can fall, except at the ends, can fall on the same place as any of the others, and that implies that there is no way you can create a line from points. A smooth continuum could not be achieved. The carry-home point was that you can't bundle points together to make a line because they are different in nature. This has a correlation in philosophy. Let's look at that correlation. Okay, bundle theory is the idea that things are just a collection of their properties, relations, and so forth. For a big red cat, its redness and its bigness in and of themselves have nothing in common. For a proton, the charge and mass seem similarly disjunct. So I'm just separating out the red from the cat there. I did it badly, but it was a nice effort. Okay, being red and being 10 metres from a house, same problem, same issue. They're disjunct. The two things don't have anything in common. The problem of bundling is there seems to be no way such differences can hold together. The information universe is affected because, like properties, information is that which distinguishes one thing from another. We could consider a list of all the aspects that make up a cat. I'll slowly gravitate toward a mathematical model here. There, it's gone. Lost it for a moment there. It was a bit scary, wasn't it? Okay, The length of the list does not matter. It could be finite or wrong one. What's it doing there? Sorry guys, there we go. The length of the list does not matter. The cat and the universe should collapse to unconnected simples because there's nothing left to hold them together. Simples of this kind are windowless, according to Leibniz, hence indistinguishable, hence uncountable, so should present as a single minimal simple. Can you see what I'm saying there? Cat, its various properties and relations, doesn't matter what they are, it's irrelevant. Even if we can't perceive them, they're still there. But we can't tell for any one of those what's inside them because they're windowless. And if they're all windowless, if you went to pick one up, oh yes, one, pick it up again, you couldn't tell whether it was one or the other one. They're all the same. So from a God's eye view, there's only one there. Okay. All right. Now, because empiricism cannot address these problems, one requires an a priori methodology. So sit physics on a bench for a few minutes. I'll give it back to you later. Firstly, ignore the world as it seems to be to us. Create a mental bag of all possible and impossible propositions, models of what there is and what there might be but isn't. This is the potential ontology from which we seek the actual ontology. To pass into the actual ontology, the proposition must satisfy Descartes' method of doubt, meaning it must be necessarily true. To do this, we first require some terms of reference, and here's the first one. There's nothing in this, by the way, it's just I had to get rid of some philosophical baggage. An omnet is just what there is or might be. It could refer to the particular or to the global. It is irrelevant. I've introduced it just to get rid of philosophical baggage. The second term of reference is asset. I've noticed that there's the plural in there is because at the beginning one can't make any assumptions about the world. There could be one or many. We will find there's one to start off with. What omnets have is assets. Supposing there to be properties as we think of them is a waste of time. We just stay with the reasoning. In that bag of omnets is an a priori version of Leibniz's principle of identity of indiscernibles, which most of you won't know. I haven't time to go into it here, it's not very important. It is a general principle of equivalence, which is a thing that we would probably expect to be at the foundation, given the work of Einstein and Galileo and many others. Now, here's the thing. Every omnet, it says, each and every omnet that has all the assets of that omnet is that omnet big deal. This doesn't look like much, just the global tautology. However, if necessarily true, it is the foundation of all analytic and synthetic propositions. It is the truth maker of those things. It is what makes them true. It expresses our idea of equivalence and difference, which is the foundation of all human understanding. It is the one thing you come into the world with, is that innately. It is the foundation of the laws of logic, which is a necessity for all consistent mathematics. We rely on the GPE being true in physics and all disciplines. It is self-evidently true, but to have ontic power, it must be necessarily and globally true. And it is. The GPE satisfies Descartes' method of doubt, which is that you should first doubt everything that can be doubted, and if you cannot doubt it, you have no reason to doubt it. So it can only be true. This statement is immune to doubt, because to doubt itself, to actually the act of doubting it, one must first accept that it is true for every doubt that one might be expressing. Otherwise, the doubt is not the doubt it purports to be. So it's just inconsistent. This holds for all propositions true and false. Consequently, the universe must comply with it, not the other way around. That's a very hard view for many of you to hear, I'm thinking. Okay, I'm saying that this can only be true. And if the world were to suggest otherwise, we'd have to question the world. That sounds ridiculous. You'll see what I mean as we go along. Okay. Being global, it must be there at the beginning. It must be first cause. Under the GPE, let me just go on now. Sorry, where are we up to? Okay. Under the GPE, I'll just call it the GPE from now on because I'll be using it a lot. The problem of bundling is inescapable other than for omnets brought to exist by the principle itself, or the condition of the world that it represents. There we are. Under the GPE, all hypothesized worlds but one collapse to a single minimal simple. Here modelled as a graph theoretic node. There is nothing outside it, no space and time or mathematics or anything. These are all lost at the first step. The origin therefore would be unique. Under the GPE, this minimal simple has the asset of identity, meaning it is what it is. This is just our way of talking about it. It doesn't add anything to what's already what you're seeing on the screen, or the model anyway. It has what it has, meaning, sorry, it has identity, has what it has. It has the asset of completeness, it has all it has, and it has the asset of being finite, because under the GPE it cannot be infinite or have extension. These assets are entangled. They form a compressive bundle. It's probably a new term to you. A compressive bundle, meaning they're all together, because they're entangled in some ways, because each has the other, so they hold together. Because this simple is finite, it has an immaterial boundary, here referring to the condition that exists because of the argument. The imaginary number I is identified in an analogous way. Under the GPE, this boundary also has identity, is complete and is finite. So this first boundary is itself bounded, then that boundary is bounded causally, iteratively, and discretely. Being windowless, the content of the initial simple is now irrelevant, whether something or nothing. Here is the second state of the rationally derived universe. The first two boundaries are modelled as vertical lines. These cannot collapse to unity because they are ontologically interdependent under the GPE. In a simple description, common assets would have them together, left pointing vector, while ontic priority as a point of difference holds them apart, right pointing vector. There's a whole bunch of philosophy relating to the background of that. I won't go there now. In a graphic theoretic form, this produces an evolving, completely connected digraph. This model that I'm showing you here is the one-space topology implied to exist under the GPE. The separation is the foundation of space. The ontic priority of boundaries, each of which brings a new state of the universe, causes times arrow. Nothing to do with entropy. 2 minutes, mother of mercy. Okay, I'll have to stop this early then. Radio. Here is the second state of the rationally derived universe. The first two boundaries are modelled as vertical lines. They can't collapse to unity. Okay. This produces an evolving, completely connected digraph. Did I already say that? Okay, third state. This produces a cosmological metronome or clock, ticking at one state per iteration. Under the GPE, each tick has the same measure. And this is the only solution that we can get from it, is there. That's the only consistent solution that I could find. It's called the harmony set. And it does this. This is how we get our universe, according to what is the only way it can go. The harmony set progresses like this. So what's happening is that the general principle of equivalence, or its modelling an actuality, acts on this like that. And then it acts on the next boundary, and we get separation, and we get more separation, and so forth. Just keeps evolving like that forever and a day. Okay, now. Each state is absorbed into the next, so the history of the world is kept, but changes incrementally. Predicting the future exactly would require a computer of greater complexity than the universe itself. It forms a discrete continuum, seeing as I've only got 2 minutes. We get a discrete continuum. In that discrete continuum, we have various mathematical forms. That actually transfers our knowledge, into the language of bits. Having to cut right through is no fun. So, how long do I have? A minute? All right, I'll have to rush through this. I'm sorry, everybody can ask me later if you're interested. The hallmark of any good paradigm is that it should throw light on issues which is not originally designed to tackle. If we follow this through, there's the way we see the Planck mass on the right-hand side, and the weird thing is the Planck mass is a very odd thing. We would expect, whereas the left ones are the minimum amounts, Planck mass is anything but that. I therefore, on the basis of the way that I grew this whole graph in the first place, was that I end up with essentially points distributed over a sphere, and associated with that, I've gone too far. All right, I know what I've done wrong. Let me just go back a little minute here, guys. This is more important. Okay. If I follow this through, the number of bits in our universe today is 6.5 times 10 to the 121 bits. It's just under the Bekenstein-Hawking information bound. That's exactly where it ought to be, unless there's no dark energy, in which case it will be half that, and actually if you work that out, actually ends up closely associated with that. The carry-home thing here is that whereas this is just a one-space model, all equivalent topologies that essentially add up to this thing here should be our universe. So when we look at the tesseract, when we look at some of the other models that I saw shown yesterday, if they're correct, if I'm correct, if they're correct, they should add up to this. And if they don't, they're not. And if they do, then they're at least one form. Because we often look at things, should we be dealing with de Sitter space, anti-de Sitter space? Are there points and particles and are there waves and all the rest of it? And perhaps the answer is all of these things connected together come together through this one space model. Okay, enough of the harmony set. Then I'm probably out of time, am I? Sadly, in the end, it shows that if I work all the way through to it, there's the beginning, and it shows that the Planck mass would be changing, and it shows that the expansion of the universe comes out naturally without the need for exponential expansion as shown by the inflationary universe. Plainly, I'll have to do that another time.
You have questions? We're kind of, there's one.
Shall I close that? No, I won't.
Okay. So I was wondering if your model implies that there is something like absolute time?
Yes. And it's not not Einstein's time, but yes, that comes out of it. My expectation is that one of the topological versions of this should give us general relativity and quantum mechanics connected.
Okay, so before that you have absolute time though, and then you get something as if you have coordinate independence? Or
Independence of?
Coordinates?
Independence of coordinates. Well, that depends, because in the very early universe, I have a situation where as it's growing, the density of energy is reducing. It directly connects with Landau's idea of information is physical. These things that we're looking at there, the connections between them, they are the bits of our universe, according to what I'm looking at. So if there is that energy associated with it, and then if I take an ontological surface, a cosmic surface, distribute them over the cosmic bound, similar to as is done with the holographic universe, then I end up with that the energy density is reducing. But the way this also implies is that Planck mass is changing, which is weird, which would imply all sorts of unusual things to do with baryons themselves. I'm not sure about other aspects, but that then implies a way by which the universe would expand, and over time the wave functions that relate to this under a Fourier transform, which is good luck trying to work through that. At some point it would decohere, and you would get independent entities in that, if that's what you mean.
Okay, so in the end you have a deterministic theory?
You know, in the end, the thing is that the position of these points ends up has inherent within it, because it's a discrete continuum, that it has inherent within it uncertainty. So that uncertainty, it's the position of the points. It's as if the points themselves, the points, the nodes, are smeared out over the cosmological surface. Very much the same way if you're dealing with Planck length squared, as we used with a black hole, dynamics, black hole information theory. Do you know what I'm saying? So we have to be very careful in the terms of the idea of a point, and the point in some.
We have to move on though,
Sure.
because we're very pressed for time.
Of course.